is a cell in which the following reaction occurs. 2Fe3 plus 2I minus gives 2Fe2 plus I2. Has E0 cell of 0.236 volts. The last case they gave the E0 cell of a particular electrode. Here they have given E0 cell itself. For the cell reaction itself, E0 they have given at 298 Kelvin. Calculate standard Gibbs energy and equilibrium constant for the reaction. Standard Gibbs energy means what? Del G naught. And equilibrium constant means what? Kc. Now with E naught cell, how to calculate del G naught? Del G naught is equal to minus NF E naught. You should remember all the formula. And I was checking in offline class, most of the students don't seem to remember the formulae. There are only limited number of formulae for each chapter, and if you are not thorough with the formula, I can't do anything. So del G naught and E naught relate formula you remember, and equilibrium constant and E naught. Okay, directly E naught and equilibrium constant related formula is log Kc is Ne naught by 0.0591. You can either use this formula directly with E naught, or since you are calculating del G naught here, how to calculate equilibrium constant for the reaction using del G naught? Use this formula. Del G naught is equal to minus 2.303 or T log Kc. Here it is log to the base 10. So once you calculate, so how to rearrange this? Log Kc is equal to del G naught by minus 2.303 or T. Using this, find this ratio, fraction value, and if you want Kc from that, find the antilog of the resultant value. Understood? Now, using E naught, how to calculate del G naught? Overall N value for this reaction, how to calculate? See, if you are not able to understand the electrons involved in a cell reaction, when you look at the overall reaction, split into anode and cathode and see what is the common number of electrons, then use the common electron value for N. Don't straight away jump into the conclusion regarding number of electrons. So let us write Fe3 plus becoming Fe2 plus electron. Why we have put electron here? Because 3 plus to 2 plus means oxidation number is decreasing, no? So whenever there is decrease in oxidation state, then it means reduction. So here I minus has undergone oxidation to I2. I minus becoming I2. Here minus 1, here 0. So 2I minus. So here electrons involved are, it has, I'm sorry, this is reduction. No, reduction means electron should be added. Here electrons are lost. So electrons, how many electrons lost? For 1I minus 1 electron, for 2I minus 2 electrons. So here 2 and 1 common number is 2. So when you are putting 2 here, you put 2 here, 2 here. The entire equation has to be multiplied by 2. So that's why this has become the overall reaction. 2 cancel. So that's why we are, when you add these two, 2Fe3 plus 2I minus gives 2Fe2 plus I2. That is the overall reaction. So what will you write for N here? 2 electrons. 2 is a common number for both anode and cathode, no? So minus 2 into 96,500 Faraday value as it is, and E naught value 0.236. When you multiply these, You get del G naught. What is del G naught value? Calculate and tell me. See, people don't seem to do anything. Huh? No response from your side. 2 into 96,500 into 0.236. 45,548 joules per mole. Or when you divide by 1000, minus 45.548 kilojoules per mole will be the del G naught. Now to calculate log Kc, let us use this formula. Log Kc is n value is 2, E naught value is 0.236 divided by 0.0591. So what is the Kc value, log Kc? Two into 0.236 divided by 0.0591. 7.98. 7.986 is coming, so we'll take 7.99. Letter 986, 4-digit number. If you have, you will get the accurate answer. 7.98646 is coming. 65 we can have. Now we see log Kc is this, means what is Kc? Anti-log of this 0.9865. What is anti-log? Nine 9.6939 is coming. So the anti-log is 9.6939 into 10 raised to the power this non-decimal value as it is. So this is Kc. Here, if you use this formula or this formula, both you should get same value. Let us check with this also. Log Kc is either use del G naught to calculate log Kc and then Kc, or either use E naught using this formula and calculate Kc. Del G naught value is what? Minus 45.548 kilojoules, no. So you have to change it to joules and use into 1000 by, or you use directly this value, minus 45,548 divided by minus 2.303 into R value is 8.314, T is 298. You cancel 45,548. Divided by 2.303 divided by 8.314 divided by 297.
298. Should get same value you are getting. 7.9826 you are getting. That's okay. 7.9826 is the log Kc value. So from that we can get Kc directly. Kc the primary value. Understood? Whether you use this formula to calculate log Kc or this formula E naught mattum putunda direct from E naught, if you are asked to calculate without calculating del G naught, straight away you can go with this formula. Sometimes in problems both del G naught and Kc will be asked. So in that case you can calculate del G naught and use del G naught to calculate Kc or E naught to calculate Kc, whichever is easy for you. Both you will get same answer only. Understood?